Let's look at some of the commonly used Oracle SQL statements used in data analytics.
So we'll now get into the hands-on. So for that, we'll be using the Oracle Apex. So log on to Oracle Apex. We'll be using the SQL workshop to just check, ensure that objects are created. So as I said, have the objects created, go into utilities, and then use the sample database. So you need to have the employee and department from the sample database to be installed, and ensure that you have the objects there. Like it needs to have objects in the sense the tables related to OEHR employees, all tables which starts with OEHR. That means the employee and the department related information or the tables are created and the data is also populated, which we'll be using in the select statement extensively. And to issue the select, get into the SQL commands. So get there, and then you need to go over, the first select from here. If you look at it, it is select last name, salary plus 300 from OEHR employees. So copy. So I'm just making a copy over here and run, and you will have all the data retrieved. So it has about 108 rows, all the employees along with the salary plus 300 it has retrieved. So ensure that if you have only this sort of kind of a blocker, so ensure that if you have only rows 10, only the 10 rows are going to be retrieved. Ensure that you have all the you have a higher number of rows. In my case, I've used the 500. The next one is, we saw this one, the first one. The next one is the concatenation. We'll run through that, move it, and paste. Then, so which means the last name is concatenated with jobs, and that is given as employees from the OEHR employees, the table. So you see a concatenation, and that is provided as the employees. Let's get to the next one. Here, if you look at it, we are having an alias as name and salary into 12, and we are making it as an annual salary. Here it is an alias over here, and name is an alias and annual salary is again an alias. So we will replace this, then run. So you'll have name, annual salary is into 12, that is salary into 12. The multiplication, the arithmetic operations are performed, and that is displayed in the output. And the final one, distinct. So for example, OEHR employees is fine. So select department, or I'll copy paste from here itself instead of typing. That will be faster. Select department. So instead of distinct, if I put department just alone, what will be the result? So it is going to repeat. So for each of the employees who are assigned to a specific department, all that gets listed. So that is where it is all repeating. The first, for example, if I say last name, comma, department, then run this. So you'll see King, Kochar, Dihon, all 90, all department 90. But what if I want to only display the specific departments? From the OEHR, you use distinct. That's the function you use, distinct. So in that case, you have one value, though that might be repeating, you have one value. So that is where distinct functions are used. So if you want to practice, go ahead, have the Apex and download the corresponding document which is there in the resources section, and have a practice. Thank you. Stay tuned. So let us now look at the analytical functions, the SQL analytical functions. And this is extensively used in analytics, particularly if you're wanted to get into some kind of a business intelligence or data warehousing, then you will repeatedly get used to the analytic functions. Whether you're using a OLAP tool, you'll be using an OLAP tool like Cognos, Informatica, or Oracle has OBIE. All this uses analytic functions. But in case of the tools, they have a built-in analytical function. But I mean, while querying to the database, these tools uses the SQL analytical functions on the background. So Oracle has introduced many SQL operations for performing analytical operations in the database. So they are the group functions. In a group, you can find out the averages, sum, min, max, and there is also, we'll see what is the null, because in case of some of the data in a particular column can have null values. So you would like to, if there is a null value, then you would like to give some values like a, I mean, they could skip. So instead of skipping, you would like to assign some values. Normally it is when you are doing an arithmetic calculations, you would like to have, when there is no value, that is the null value, you would like to have 0 enforced. So then you'll use the null there, null functions. Then there is a group by and having. There is also interestingly the roll up and cube. The cube is what is generally used in the data warehousing. Cube is nothing but the cuboid or a Rubik's cube, which has different faces, different sides rather. So it's basically slice and dice. You like to view it in a different way based on the time period. You like to see it, what is happening on the region basis, how your product is doing on the time basis, on the region basis, and so on and so forth. So different dimensions will be there towards analysis so that you can derive out meaningful information from there. So you'll use a cube function. The roll up and cube is specifically data warehousing, and in fact many of the I've seen many of the SQL classes, they don't really touch upon the roll up and cube, but roll up and cube is very essential for data warehousing. And that is where, I mean, once you go into the data warehousing or business intelligence, and they have to make I mean, when you have a class, I mean, people tend to may not have really understand what is roll up and cube. But fortunately, Oracle has that function. I mean, the SQL has that function, the roll up and cube. So we'll see that with an example also, how that works. So the type of, we'll split in this into 3 different parts. First, we'll, with an example, we'll look at this one first, and then subsequently we'll look at the group by and having, and finally we'll look at the roll up and the cube part. So type of group by, group functions, not group by, group functions, average of a group, count, max, min, sum, even standard deviation, variance is all there. I mean, it's just a function, so you can directly use them in the SQL statements. So this is, I mean, you can always find out, try to find out the max of salary from the employee tables. That is an option. But if you want to go by the department, then you can use the group by. This one gives the maximum of a salary from, just select max salary from OE, HR, employees, that will give a maximum. But if you want to have it department wise, then yes, naturally you need to have a group by there. And similarly, you can have the average, max salaries, min salaries, where the job ID, like something like this, you can try out with the average, min, max. Similarly, you can find out min hire date, max hire date, and you can also use the count function is where, I mean, this is just a counting total in the employee department ID 50, what is the count? So, and again, count of the commission where the employee ID, and this is where returns number of rows with non-null values in the expression. So if it is null, it will not take that into account. And finally, the NVL function. This is where it gets interesting, the NVL function. So when you give that select average of commission, what it happens is, suppose assuming some only 5 employees has the commission. So in this case, what will happen is wherever there is a value, it will take that and have a count. So suppose only 5 employees have a commission percentage. So it will take only 5, even though there might be hundreds of rows, only 5 of them is going to have the commission. So it will take only 5. So whatever the value divided by 5 will give that average. Whereas this one is what is NVL, because NVL is there. Wherever it is null, it will substitute with a 0 value there and then provide the average. So if the table is going to have 100 rows in that, so it will get divided by 100, because whatever, if value is not there, it is null. So it will substitute with a 0. So if there are 100 rows, it will divide by 100. So there is a difference there. I mean, though it is the function is average, because you are using the NVL, and the result is going to be different. So we'll see that I mean, while working through the demonstration. So thank you. Stay tuned. Let's now look at the demonstration or hands-on. So for that, I logged in into the Oracle Apex. So I've already run this query, so pretty straightforward, but I just wanted to, I mean, you to understand that this is just a grouping function. So average salary, min max salary, where job ID, this is a wildcard. In the earlier discussions, I showed about the wildcards, so which we use the like statement. And if you run it, okay, I think I'm not logged in. So I have logged back and ran it. So yeah, yes, it gives the average, max, min, and sum of all the salary for the wildcard REP, where job ID is like REP. So the rest of it, I mean, if you run through it, yeah, before that, we'll also see this one, the group function using the max of salary from the OE employee tables. We'll run that. Just write the query, select max of salary from OE HR employees salary from HR employees. So this is the max of salary from all the employees. But if you want to go by department, then you can use the group by department ID. And you can also include department ID. So I have rerun it, just made additional spaces where there I removed it and rerun it. So max of salary department you have, so you know based on the department. So it's a kind of a grouping, it happens. So it groups the department, and in that group of department which has multiple salaries, and from there it derives out what is the max salary. So it's 8,200 whatever USD or Japanese yen or whatever. So that is we are just ahead. I mean, we'll be seeing that group by group by class, but I thought, yes, it's far more easier to give you the knowledge through the discussion. So I said, I talked about the group by class. So now we'll just progress with the, so this is the group by function. We saw this. All this, I mean, I would suggest, yeah, if you really require, you can run this and see what happens. Yes, basically it is going to get the minimum of the hire date and the maximum of hire date. So, and similarly, the count. So total count, you can run this. So whichever whoever is in the department um, 50 will get listed, and you can run this also, returns the number of rows with not null with the expression. But I just want, so if there is a commission, then it is going to return. I just want to show you this one. I mean, this one, it is going to give you the average uh, so this gives you the average. So basically, when it is null, it is I mean, if there is no value in that specific column, then it will not take that. Wherever there is a commission value, it includes that and then performs that averaging. But the other way is that if you want to have that for the entire list of all the employees, then you need to add the NVL over here. NVL commission, comma Z. So we are saying that you also include the commission. I mean, include if there is null. So include that. I mean, for that you're just passing a 0 there, and then if there are 100 employees, for all the 100 employees, it will take the average. So what do we expect? The value is going to be higher, or is it going to be lower? Can you make a guess? Or logically, earlier when there is a blank, it is going to take only whichever the rows which has the valid value. So you take only 5 has the valid value, averages out divided by 5. Here in this case, if there is 100, even when there is a null value or no value, it is going to substitute with a 0. And so if there is 100 employees, it is going to divide by 100. So naturally, you run this, you will find the value is less because it is substituted wherever there is null, it is substituted with 0 and divided by the total number of employees. Total number of employees in this table, I think it is 108. So divides by 108. That is where it becomes even less. The average commission becomes even less. So the NVL command is quite handy. It is used extensively in all, I mean, in all the analytics, in the reporting, in the data warehousing. So have a good grasp about the NVL commands. I think, yeah, this is done. And next one is actually the group by. So we will take that group by in the next presentation. Thank you. Stay tuned. Let's now look at the group by function in detail. So if you want to, as I had discussed earlier, if you want to make it a little group, smaller groups, and then make a comparison, just like smaller groups based on the, for example, department ID, and then you can perform the functions as we have seen earlier. What is the max salary of employees? Group by a department. So for each of the department, it is going to group and then look out for the max value in that group. So that is the main function of a group by function or a group by class. And here is the syntax for that group by, and then there is an order by as well, because if you want to order by department, you want to start find out the maximum salary, group by department, and then you can order by the department, meaning you want to order by like start with the lowest one and then you lowest one, the sense maybe you have department as 10, 20, 30, 40, so that there is a, that there is a uniformity. So that is the order by. So this is just a pictorial representation. You see that we have seen that I have just demonstrated also. You just group by the department, and then it gives out the here. I mean, if you try to average out the salaries, it averages out the salary. So this one, we'll see that we'll run it and see it. One is that it is based on multiple columns. One is department ID and job ID. And then finally, we are ordering by a department ID. Only thing is, we also have var class. So anything less than the department 40, we don't want. So department ID is greater than 40. Only those departments we want, and then we are using a group by class to group by the department ID and job ID and the order by the department. So another one is, then you can group by, and then you can also have a having class. After group by, only if the salary is more than 10,000, you want to list that out. If the salary is less than 10,000, you don't want to list it. So that is what you group by department ID. Then you use the having, so that you find out when the max salary is greater than 10,000, then you list it out. So that is the having class. So we'll see that in the demonstration how it works. Thank you. Stay tuned. Welcome back. Let's now look at the roll-up and cube operators, which can be done through the SQLs. As I indicated earlier, the roll-ups and cubes is very common in the data warehousing. That is the OLAP in OLAP reporting. Any kind of business intelligence application or reporting, you hear out the roll-up and the cube, not only the roll-up, the drill down also. So, I mean, through the SQL itself, you can achieve the roll-up. And drill down is something like, it's something like, okay, for the year 2020 or 19, this is the sale. And then you drill down further, like quarter basis or half yearly basis. And when you click on the specific quarter, then it will go down and give you details about the monthly basis on which the sale has happened. So that is about the drill down. The roll up is just opposite. So from month, you can roll up to a quarter. What is the sales for a quarter? And you combine the quarter and make it the half yearly sales. What is the half yearly sales? And finally, the yearly sales. That is the roll up. So basically, it boils down to drill down is getting the details, granular details as much as possible, and roll up is more of a summary level. So all this is achieved, the roll up is achieved using the SQL function. We'll see that. And cube is something like this diagram. If you see, if you take TV, as you know, the cube has different faces. So if you take TV, you can go by region or geography. What is the sale in USA, Asia, Australia, and Europe? And then quarter on quarter basis. Quarter basis, it will combine USA and Asia as well. So the entire region is combined, but on the time basis, what is a sale on quarter, Q1, Q2, Q3? This is in a different phase of the cube. So, and again, cube is common as well in the business intelligence or OLAP or data warehousing. It's so common in the cube. So it's kind of a, if you look at it, it is multi-dimensional. You look at different dimension, you analyze the data and try to derive out a meaningful metrics or details so that the company can focus on the future sales based on that. Just as an example, assuming Q3 sales is high, it has gone very high, and if you look at it, probably the reason, then you look at it and then you find out the Asia sales in Q3 has gone up, whereas the other regions are almost same, then okay, it is Q3. The difference is because of Asia. So maybe that's a festival time or holiday time, whatever. Then in the future, you can use that information for your business intelligence. So you know, like, okay, Q3, we have a solid proof that the sales in the last year was so very high. So this year it's going to be high. So ensure that you have sufficient stock of TV in all the retail stores, so that I mean, you don't end up in a situation where there is no stock of TVs. So all this is possible through the cube. So this is the syntax. So it's actually extension of the group by, and I said cumulative aggregates. And if you look at the syntax, it's almost same like a group by and having, except that you use roll up over here. We can see that in the demonstration with an example, then it will become much more clearer. And similarly in the cube as well, if you look at it, it's almost same. You use the cube over here. So you can use cube operator to produce across tabulation values, single select statement. So, and as I said, provides the multidimensional view of data, querying and analytical capabilities. So we'll take a example and try to query out and see what happens. So thank you, stay tuned. Let's now look with an example, both the roll-up operator and the cube operator. So this is the query we are retrieving from the employee table. That this should be OEHR. In fact, in our case, it is OEHR, that is in Apex. So OEHR employees, department ID is less than 60, roll up by department. So when we run, sorry. So when we run it in the Apex, you will get this result. If you look at it here, you have a grand total by department. It additionally provides, then it provides the grand total as well. So your basically the roll up gives that information, and these are the details. These are the details for 20, and these are the details for 30, and this one is the roll up value. So otherwise, yeah, we will run the query without the roll up and see what happens, and we incorporate a roll up, we'll see what happens. And similarly in the cube as well, we will see that I mean, if you look at it, it provides by the job ID and then by the department ID as well, and the grand total as well. The grand total, and when you have just a group by, you don't have the grand totals provided. So we'll run through the query in the Oracle Apex and see just with the group by, and then by adding the roll up and cube operators as well. So I have run this query, the roll up with the roll up, and you get the result. You get the aggregate total for each of them. But when I run it without them, without this, it will be group by just the department ID and the job ID. You will not get the additional grand totals. So you don't get the additional grand totals. So just the department ID and the job ID, you don't get the grand totals. So similarly, we'll see with the other one, which is the cube. So this is with the cube. You have the grand total on the top, as we have seen, and then this is with the job IDs, and then you have the department wise as well, because we have included department ID as well. And the one of the feature with the Apex is that you can download, and download in the sense it comes in a CSV format, then which means a spreadsheet format, and use the spreadsheet. Maybe you can give names as grand total, because it is provided once you download, because it comes in a spreadsheet. You can then format the spreadsheet. That's an advantage as well. And again, just if you use the group by alone, yeah, it gives the department ID and job ID. When the job ID is different, you have it gets twice. if you see here, as far as 30, it is only PU clerk. It doesn't have another job ID. Another job ID. Okay, here you have PU manager as well. And 50, you have 1, 2, 3 times. 10 has only AD assistant. You don't have another job ID. So it gives much more. I mean, using the roll up and the roll up and cube provides much more detailing. And as I said, you will keep hearing about the roll ups, cubes, drill down as you progress into the analytics, particularly in the data warehousing or business intelligence. So that way you will now have some understanding, I believe, on the roll ups, drill down, and the cube. Thank you. Stay tuned. Another interesting function, which is hierarchical retrieval. Generally, this kind of hierarchical retrieval, generally in SQL statement, we rarely use it. But once you get into data warehousing or business intelligence, the hierarchical operations, top down, bottom up, uh, roll up, then drill down are commonly referred. And there are functions as well for even for hierarchical retrieval. We'll see that now. So hierarchical query or hierarchical query is possible when there is a parent-child relationship exists between the rows in the table. So in the employee table, you have the employees reporting to a manager. So it's a kind of a parent-child relationship. And you can, as I said, you can use the hierarchical queries for the top-down and bottom-up. Both you can use top-down and bottom-up. So if you look at the syntax, select star from table, the whatever is given in the rectangular box, whatever that is provided, this is important. Condition connect by prayer. And that determines actually the direction, whether you want to have the top down or bottom up. So that is that prayer plays a critical role. So in case of here, in case of the top down, prayer employee ID to manager ID, and all that is, this provides the direction, and you need to reverse it. So you need to reverse it in case of bottom up. So if you look at we'll look at the employee table as such. This is how the king, I mean employee name by king is at the top position, and these folks, the level 2 folks, report to king. Actually, if you look at the employee table, king will be he is each of these employees has the manager ID as 100, and 100 is king. So this is at the level 2, and then you have level 3, and finally level 4 employees. So you can use there is a pseudo column as level. In fact, you can use them along with these hierarchical condition for your for retrieval. So this is again an example as how it appears. We'll run this query, and you'll see this output is something like this. As I said, king will be at the top, and then followed by the other employees along with the employee ID, and it gives these are at level 2, level 3, level 4, and so on. And again, in the bottom up, you have prayer manager ID equal to employee ID, and in that case, bottom is this one, it goes up, king is up. So in case of reverse, you take employee ID over here and then provide the manager ID. So what will happen is whoever Kochar becomes the topmost guy, and whoever is reporting to him like the next level, so it goes down. So top to down, and this is bottom up. So you will understand much more clearly. I mean, we'll run this also. Basically, it's going to give the, I've taken the screenshot. So it will provide you with the same output I have provided in the, as provided in the screenshot. You'll have the same output when we run this in the SQL command line. So let's see that. Thank you. Stay tuned. Let us now run this hierarchical function in the SQL command and see how it looks like. The first one is the level operation. I mean, using the level pseudo column, it gives you the different levels. For example, I mean, in the employee table, we have 4 levels. The top level is king, and there is a next layer that is referred as level 2, level 3, and level 4. So if you run it, yeah, this is what we get for all the employees with the managers. So it starts from king, then at level 2, then you have level 3 also, level 4 employees as well. This is with the level 4 pseudo columns. Then moving on, the bottom up, which starts with employee 101. We don't want employee 10 bottom, that will be at the bottom, and over 101 reports to, it will have that displayed. The critical point is when you have the bottom up is this one, this column, manager ID and employee ID. So this is bottom to up. You run this. So you have Kochar who reports to king. You have a manager ID, so he reports to king. So this is bottom is Kochar and up is king. And now whoever reports to Kochar, that is top to down from 101, which is Kochar's employee ID, and we want to take it down, whoever is reporting to him. Yeah, you get this one. It starts from 101 and it goes further down. So that way, I mean, you will also know who are the employees and who are the how is the top down looking at, or how is bottom up looking at. So the interesting part or critical part is the connect by prayer. That plays a significant role. Which one is the parent, which one is the child, that determines the bottom up or top down. I hope you now have a fair idea about the hierarchical operation. Thank you. Stay tuned.